Now, question 4 here, it is the continuation of part 1. So this is part 2. We are starting off from question 4. We are given here a diagram, which is a triangle with the vertices A, B, and C, and the given coordinate. Now, the first question says, determine using any method the coordinates of D if ABCD is a parallelogram. Now, we are not told in which quadrant do we find this point D. So we can assume that it is in any of the uh, quadrants. So since the examiner told us to use any method, I'll decide to use here the method of construction. So as I said, we're going to assume that it can be in, let's assume that it is in here. So we're going to construct here our line here, which is going to complete the parallelogram. Now it may not be that straight, but yeah, that could be our parallelogram if it's complete. And that will be the point D. Now, how do we calculate that? I normally use this method where you subtract the coordinates. So you can say here for subtract 1, if you just do this, the x value at b minus the x value at a, so that is going to give me 3, and the y value at b, which is 3, minus the y value at a, which is 5, and that is going to give me negative 2. Pardon my 5, that's negative 2. Yes, so what happens here is that these values that I get here, 3 and negative 2, they tell me how many times do I have to move from A to B horizontally and vertically. So 3 here, because I found it by subtracting the x values, that is going to be my horizontal movement, and here it's going to be my vertical movement. So from I'm going to move here from point C, starting from 0 horizontally. I'm going to move 3 units to the left. So starting from 0, 3 units to the left, that is going to be negative 1, negative 2, and negative 3. So the point here at the x value is going to be negative 3. That is the horizontal movement, and vertically I have to move upwards, but I'm going to start where at negative 3, because vertically I use the y values. So that is negative 3, negative 2, and negative 1. So because I only move 2 units, that is going to be negative 1. So the coordinates of D here is going to be negative 3 and negative 1. They are both negative, as you can see that we are in the third quadrant, and in the third quadrant, both x and y are negative. So that's how you can do that. You can use any other method that you had taught, but I prefer this one because it's only 2 marks for now. So the next question says, if the distance between C and F is given as a point there, which is 8, and P is 12 units, the distance is 12 units, determine the value of values of P to the nearest integer. So grade 11, so we are given the distance between 2 points. So we are forced basically here to use the distance formula. So I'm going to do question 4 point. Okay, we've already did question 4.1. Here it is answered the coordinates of D. That's negative 3 and negative 1. So I'm going to answer question 1.4.2 here. So we are going to determine the distance between F and C. So let's call it distance FC. So we can just substitute here. The coordinates, we do have the coordinates of C. So remember that is x1 minus x2 in this case. So that is going to be um, the x at C is 0, the x at F is 8. So I'm going to take the x at F, that is 8, minus the x at C, which is 0. Then you square that, plus the y at F, which is P, that is going to be minus 3, then that is going to be plus 3. So it's You subtract the negative number is the same as adding that number. So that's what we have now. So remember now that the distance was given here as 12. So since it was given as 12, I'm going to substitute FC as 12, and then I'm going to go on and simplify inside the brackets. 8 minus 0 is 8, and 8 squared, that is going to give me 64. And the next bracket here, we need to simplify by multiplying it out there. That is, you can quickly do that. That is p squared plus 6p then plus 9. Then what we can do is that we have to remove the square root. So we're going to square both sides so that we remove the square root here. So the square root and the square are going to cancel. And on the left hand side, you've got 12 squared, which is 144, equals to what is left inside the bracket. So that is going to be 64 plus p squared plus 6p plus 9, because the square root and the squares are cancelled. So in this case, you can just group all those terms together on one side of the equal sign, because I can see that we need to factorize. We've got a nice trinomial here. So that is going to be our p squared plus 6p. Then you take 144 that side, you say 64 minus 144 plus 9, or however you want to do it. But when you add all of them together, they give us 71, and that is all equals to 0. I hope everyone can see that. So in this case, for you to factorize this, oh my god, we can't just do that now. So in this case, we can use the quadratic formula as you know it. X equals to minus b plus minus the square root of b squared minus 4ac divided by 2a. Then you substitute all the values. That is going to be negative 6 plus minus 6 squared minus 4 times 1. Then our c is negative 71, all divided by 2 times 1. Well, a is 1. Then when you put everything in your calculator, I set x and we are calculating p here, so I should change that to p, because that's what we are calculating. But remember, the quadratic formula is x equals to, so that should be p there, and your p is equals to, when you put everything in your calculator, you get two values, which the first one is 5,94 with the plus sign. Then you change that to a negative sign, then you get p being equals to negative 11,94. So the set that this should be to the nearest integer. So we should round this to the nearest integer. So it means our p is going to be, for the first one, because it's 5,94, the nearest integer here, you can see the number after a comma is greater than 5, so that is going to be 6, or p here is going to be negative 12. So that's how you do that. If p is on your right hand side in this case, but anyway, f is 8, that f is the x value, so p should also be on your the value of p in this case is going to be minus 12. I think it's going to be minus 12 because it's below the x-axis. Okay, but anyway, we're not told whether the line is going up or is going down, so we can just leave it as p equals 6 and p equals to negative 11 in this case, because we're only told to calculate, to determine the values of p, so we can leave it just right there. Then the next question says, determine the size of a angle CB. So A angle CB is the angle here, which is what I'm just highlighting now. This is the size of the angle that we need to calculate. Now you need to be able to remember the properties of a triangle. Remember the properties of a triangle. It's that the angles of a triangle add up to 180 degrees, and the exterior angle of a triangle is equals to the sum of the opposite interior angles. So normally this is what you use here together with the gradient to determine the angle that is not known. So in this case, for us to determine that angle, we need first to determine what is the value of theta and what is the value of beta. So what you can do is that, because you can see that those are the angle of inclinations, so we need to use the formula that you know very well, that is the gradient formula. But in this case, we're going to use it with tan theta. So m, which is the gradient, is equals to tangent of theta. The theta, remember, it can be any um, angle. So it can be beta, it can be alpha. So we're just representing the angle there using theta. So we're going to go on and calculate the gradient of BC so that we can find theta here. So you can just say what 3 minus negative 3, that's y2 minus y1. So that is our y2 minus y1 and x2 minus 0, which is x1. So that is going to give me 6 over 4, which can be simplified to 3 over 2. Now we use this formula, m is equals to tangent of theta, so that we can calculate the value of theta. We know the gradient is 3 over 2, so we're going to go on and substitute the gradient, which is 3 over 2, equals to the tangent of theta. Since we're looking for theta, we're going to take it as a subject, and remember, you take what? The second function, or arc10, over that fraction, which is 3 over 2. Then you use a calculator, then you get your theta as what? 56.31 to 2 decimal places. That is theta. Now we can go on and calculate beta again here. So we also need the gradient of AC. So that is MAC. Also here y2 minus y1, that is 5 minus negative 3, which is 5 plus 3. I don't think you're going to be confused here, because it's 5 minus a negative number, which is just plus, and again that is 1 minus 0. So 5 plus 3 is 8, 8 over 1, that is just 8. So we go on and calculate the gradient. We calculated the gradient, so we're calculating what? Because we used AC here, the angle at AC is beta, so that is going to be m is equals to tangent of beta in this case. Then that is 8 equals tangent of beta. To find beta, we take the arcsine, or second function of tan, and that is 8, which is basically 8 over 1. You can just make it 8 or 8 over 1, it's totally up to you. Then your beta here is going to be equals to, in our calculator, that is 82.87 degrees. So we have those two angles. Now what we see here, the x-axis and line or side BC here, they are crossing each other, and they are forming here the vertical opposite angles. So the theta outside there is equal to the theta inside this triangle, because those are vertically opposite. I hope you can see that we have just drawn the theta there. Those angles are vertically opposite. Um, so when you look at this, we've got now a triangle with the exterior angle here. We've got this triangle here with the exterior angle beta. So beta, you can see that this line is extended outside, and that forms the exterior angle. It forms the exterior angle there. So the exterior angle of a triangle equals to the sum of the two opposite interior angles. That is one property that you can use. So you're going to say that your beta is equal to the sum of the two opposite interior angles. So those two opposite interior angles are this theta, which is inside, and the angle ACB. So that is equals to the sum of theta and angle ACB. So we do have those. Theta is 82,87 and equals your theta, which is 56,31, and plus this angle that we are looking for. So from there you can just subtract 56.31 on both sides. Therefore your ACB is going to be equals to 26,56, and that's how you do that. Um, it's quite hectic, but yeah, that's how you do questions like this. Don't forget that you need to study the properties of different quadrilaterals so that you'll be able to answer questions based on the quadrilaterals in your grade 11 um, geometry, analytical geometry. Now the next question, question 5 says, in the diagram below, the diagonals of STVW are equal in length. That is very important. You should note that those diagonals are equal in length and they bisect each other at P. Then calculate the coordinates of T and W. Ooh, wow, what a question. Okay, so you'll be asking yourself, where do I start? Where do I start with this question? The information that is given will definitely lead you on where to start. We are told that the diagonals of this four-sided figure STVW are equal in length. So since we are told that they are equal in length, somehow we have to use the distance because the length is given that it is equal for both diagonals. So somehow it tells you that you have to use the distance. So we're going to use the distance, calculate the distance of what? Of what we know. And what do we know? The coordinates of V and the coordinates of S. So it means to calculate the distance or the length of um, Vs. That's what we're going to do here. So let's start off and do that. Vs or SV is totally up to you, but most people prefer to follow the alphabetical order. So the distance formula, you don't have to keep on writing the formula always. So that is going to be, let's choose V as x1 and x2. So that is going to be 3 minus negative 1, which is 3 plus 1. Remember, we're subtracting a negative 1, so it's the same as adding. Then that's plus 2 plus 1 again. And in brackets, that is 3 plus 1, which is 4. 4 squared, that is 16. Or you can just use a calculator to do everything at once here. That is 16 plus 9. That is going to give me 25. And you take the square root of 25, which is 5. You don't have to put a plus minus in this case because we are calculating the distance. We know that in most cases when you've got the square root sign, you have to put plus minus. But in this case, you're only calculating the distance. So that is going to be 5 units. Then from there, what else was given? We are told that the diagonals also they bisect each other at P. So bisect means they cut each other into two equal parts. So it means that P here is going to be the midpoint of both the diagonals because that's where they bisect each other. So it makes that this diagonal to be equal to that diagonal and that one to be equal to that one. So it means P is the midpoint. So since we can see that P is the midpoint, let us go on and calculate the midpoint of P. So we're going to say the midpoint of P. Let me try to use a different color. Um, Remember that is x1 plus x2 over 2. So I'm going to choose negative 1 plus 3 divided by 2. And also the y's starting with negative 1 plus 2 divided by 2. Then 3 minus 1, that is 2 over 2. That is going to give me 1. That is the x value. And 2 minus 1, that is going to be 1. And that is going to be 1 over 2. So it means point P here is 1.5. So remember the question says we should calculate the coordinates of T and W. So how do we do that? But there's something very interesting about this diagram. We are given the right angle, which means TW is perpendicular to the x-axis. And what does that mean to us? It means then that TW is a straight line which is basically parallel to the y-axis, since it makes an angle of 90 degrees with the x-axis. Because you know that on your Cartesian plane, the y-axis and the x-axis, they are basically perpendicular to each other. So since TW is also perpendicular to the x-axis, it tells us that TW is a straight line up from T down to W, just like the y-axis. So which means they share the x value here. They share the x value. So if you can find out what is really x there, the x value is 1 basically at P. So it means also at W the x value is 1, and also at T the x value is 1. I hope you do understand that. So that's the reason why we are given that this is perpendicular here. So that they all share the x value. So we can just only write the x value because that is what we know. For both of them, the x value is 1. So how are we going to find out the y value? I think the distance that we calculated there is going to help us to find the y value. So since the distance SV is 5 units, and we are told that these diagonals are equal in length, so it means that TW is also 5 units. So if TW is 5 units, let's see what happens here. So 5 units from point P to point T, it's half of 5 units. So that is going to be what? 2,5. So the distance from here to here to point P, that is going to be 2,5. And also the distance from here to there, that is 2,5. Because we're told that the diagonals bisect each other and the total length is 5. So they share that 5 into 2 equal parts, which is 2,5 and 2,5. But we know that at P, the y value is a half. So from the x-axis to P here, we've got a half. So what is left to make the remaining distance? That is going to be 2. That is going to be 2. So remember that we've got 1 here and a half. So it means at T, the y value here is going to be 3 because we've got 2,5 from T to P, and the distance from P to the x-axis is a half. So that half plus 2,5 it give us 3. So that is going to give me 3, and that is 3 there. And from P to the x-axis, that is also 0,5, and the total length is 2,5. So what is the remaining length from the x-axis to W there? That is going to give me what? 2, and because it is below the x-axis, and that is going to be negative 2. And that's how you calculate the coordinates of T and W. Quite a strange question, but yeah, it needed you to understand exactly what is really happening there. You can just watch the video time and time again, and so that you get the gist of what is happening here. Now the next question, that is trigonometry. Question 6, trigonometry, 6.1. It says if negative 3 sine beta minus 2 equals 0, and beta is element of that restriction from 0 to 270, or the domain, use the sketch in the correct quadrant to determine the value of 1 plus 10 squared beta without using a calculator. So in this case, you just have to use the sketch to do that. So before we can use the sketch, let us go on and make sure that we write the given equation in the standard form. So that is the given equation. We should write it first in the standard form. So how do we do that? We should isolate the ratio and its angle. Anything else that is either multiplied or added or subtracted must be eliminated or taken to the other side of the equal sign. So remember that whatever that is added or subtracted is the first thing that you have to remove. So here we've got 2 that is subtracted. So you have to remove 2 by adding 2 on both sides. So you're going to go on and say negative 3 sine beta. Then when you add 2 on both sides, they're going to cancel on the left hand side. Then on the right hand side, 0 plus 2, that is going to be 2. That is the first thing that you do. The next thing that you do, you divide by negative 3 on both sides. So you divide by negative 3 on both sides, they're going to cancel on the left hand side. And you also divide on the right hand side. So that is going to be negative 2 over 3. So always when you dealing with this kind of questions, you must always make sure that you write the ratios or the given equation in a standard form, meaning that the ratio should remain by itself, and any number that is multiplied or the coefficient of the ratio should be on the other side, and also what is added and subtracted. In this case, 2 is subtracted, so that is why it was taken on the other side. So that's what you do there. Now, after doing that, remember that your SOHCAHTOA, that sign is the opposite over there. I'm going to write it down here, but okay, let me use the definition. Opposite over there, hypotenuse in this case. So the opposite here is normally y, and that is r. I prefer this one actually, y over r. So that's how you can do that. Now, in this case, it means we are given 2 sides of the triangle. Remember, these ratios, they work with the triangle. So what we're going to do here, since the examiner told us to um, use the sketch, we're going to draw the sketch, and that is what is going to lead us to see what is happening here. Okay, my lines are not really that straight, but yeah, that is your y-axis and your x-axis. Yeah, that looks bad. Looks really bad. You'll pardon me for that. Should I also have to use a different pen, a different color? Let's try to draw a line that is going straight downwards in there. This is way much better than the previous one. So yeah, from there we've got what? Beta, which is normally the angle, the reference angle in your first quadrant. But let us look at this. We've got sine, which is negative. And which quadrant do we find sine negative? Remember, in your first quadrant, they're all positive. In the second quadrant, only sine is positive. And in the third quadrant, sine is negative. And the restriction says that we should only start from 0 to 270. So we're not going to focus on the fourth quadrant because that is beyond 70. So it means then that our diagram is going to be in the third quadrant where sine is negative. So you draw the arm from the origin into the quadrant. Oh my god, why am I so clumsy? Okay, let's try it again. Still clumsy. But anyway, that's fine. So we reach a point there. Um, we can just complete the triangle with the dotted lines. So this is our y here, and this is our x, and that is our r there. So from the definition, we can see that our y is negative 2. So we've got negative 2 here, and our r is 3. And your r is always positive. So it means we need to go on and calculate what? The value of x. And what do we use? We use the Pythagoras theorem for that purpose. So we're going to say the Pythagoras theorem, as you know it, it says r squared equals x squared plus y squared. So since we're looking for x, we're going to make x the subject of the formula, which means we're going to say x equals, it's always the hypotenuse squared subtract the other side, which is y squared. It's always like that. So that is going to be, the hypotenuse is 3, that is going to be 3 squared subtract negative 2 squared. Then you can just go on and use a calculator there, which is going to give you 5. But remember, this is in the third quadrant, so your x is negative, so that is going to be negative 5. So the negative square root of 5, because we have to remove the square root of, that is x squared. So x, it's a negative root of 5. Then we are told to determine the value of 1 plus tan beta without using the calculator. So for that purpose, we answering the question now. 1 plus, this is all you need to do. You need to do all those things before you can answer the question. So that is going to be equals to 1 plus tan, remember, is the opposite over the adjacent, and the opposite side is negative 2 over the adjacent. In this case, that is negative, that is our y, and everything else should be in the brackets because you're going to square that. Then you can just use a without using a calculator anyway. So without using a calculator, we're going to say the plus and the negative signs inside the brackets are going to cancel. So we're going to have 2 squared. So that is going to be a plus 2 squared, which is 4, and the square root of 5. The square root and the square are going to cancel. Then are going to be left with 5. So you proceed by saying 1 times 5, which is 5 plus 4, and that is going to be 9 over the denominator, which is 5. And that's how you do that. That's how you do this question. Um, you should be able to do all these things. Remember, whenever you're given the ratio, make sure that you write it first in a standard form, and then determine in which pattern are you going to draw your sketch by using the restriction or the domain. Then determine the other side which is not given or which is not part of what you have there. In this case, it was x. Then from there, once you have all those, you can calculate any of the questions that they want you to determine. Then the next question says, if cos 75 equals m, express each of the following in terms of m, showing all your working in this case. So it means you don't only write the answers, but you must show all your workings. So the first working here is that it is not really different from the previous one, because in this case you still also have to find out what are the sides of the right angle triangle, because remember, when you're dealing with these ratios, you need to find all the sides of your right angle triangle, because that's what expresses or define these trigonometric ratios, that is the opposite, the adjacent, and the hypotenuse. So I'm going to do it here. I'm going to draw our right angle triangle. Pardon for me being this slow. That is our right angle triangle, and we've got cos 75 equals m. And remember that this is always a ratio, so it's always something over something. So this is always a number over a number. So in this case, the variable m over 1. So it's always like that. So how do we define cos? Okay, we should define cos by looking at which angle are we talking about. So I'm going to put 75 there. And remember that angles of a triangles add up to 180 degrees. So since we've got 75 and 90, we've got 15 that is left to make up 180 degrees there. So with respect to 75, this side is going to be the opposite side, and this side is it's always the hypotenuse, and that is your adjacent side. Those who prefer the y's, the x and r, that is how you can do that. All right. So Again here, I'm going to change the pen so that we don't confuse what I'm doing together with this one. So cos is the adjacent over the hypotenuse. So our ratio is m over 1. So m is going to be the adjacent, so that is going to be m here, and our hypotenuse is going to be 1. And remember that whenever you use this triangle, the other side, if it's not the hypotenuse, it is going to be the hypotenuse, the square root, sorry, the square root of the hypotenuse minus the square hypotenuse squared, which is 1 squared, but it remains 1 anyway, minus the square of the other side. So this is always the case. It happens always. So if you have got the hypotenuse and the other side is going to be the square root of the hypotenuse minus the square of the other side. It's always like that. So that is what we're going to have now. So once you've got this triangle here, um, everything is easy now. Everything is going to be easy. The first question says we're going to have to express what? Cos squared 105. So we can just go on and answer everything just right here. So we need to reduce 105 because we've got 75 there. We need to reduce 105, or 75 should be part of what we are dealing with. So how do we deal with that? 105, it is in the second quadrant, and in the second quadrant the reduction is 180 minus. So we're going to go on and say this is equals to cos 180 minus 75, and it is squared, so everything should be squared. So it means I'm going to need some brackets outside so that we square everything there. And it is in a second quadrant where cos is negative, so that is going to be negative cos 180 minus, that is going to be cos 75, and that is still squared. So I'm going to proceed here. So here you can see that it's negative cos 75, so that is going to be what? Negative m squared, which is just m squared. You don't have to do all the steps. I'm just doing everything so that you can understand. If you don't understand, you can always go back and see how did I do everything. So that's how you do that. Then the next one, I'm going to do it down here, 6.2.2. You've got sine of 15. Fortunately, 15 was one of the angles inside the triangle there. So, but in this case, when we use 15 here, the opposite and the adjacent are going to interchange. But one thing about what I see here is that 15 and 75 are complementary angles. So having sine 15 here is going to be the same as having cos 75, because remember that sine 90 minus 75 is the same as sine 90 minus 15. So in this case, cos 90 minus 15, because those are the complementary angles. So sine 15 is the same as cos 75, because when you add 75 and 15, you get 90 complementary angles. So that is just going to be m in this case. That one is quite easy. Then the next one, 6.2.3. Um, tangent of 15. So you can just go on and use the diagram as it is here. Tangent of 15, that is going to be the opposite over the adjacent. So, but our opposite in this case, with respect to 15, our opposite is going to be this side. With respect to 15, the opposite is going to be this side, and that is going to be the adjacent. So with respect to 15, that is the adjacent. So remember, this sides always change depending on which angle are we interested in. So in this case, The opposite side is m, and the adjacent is root of 1 minus m squared. And that's how easy you do all these things. Tan, you can also use sine over cos. That's going to work. But for now, that is what we are going to use. Then the next question says, here, given the expression, that long expression, you need to simplify the expression. So how do we simplify such expression? We're given these expressions with the reductions and core ratios, negative angles, but everything in terms of k. So it means then that we need to rewrite everything and put that in terms of k, write everything in terms of k. So we use our reductions, as we know, we use our cast pattern, the cast diagram, as you know that. So we're going to go on and simplify this. I'm not going to rewrite the equation. I'm going to move from the equation, but starting with the second step. So cos 180 minus, that is in the second quadrant. So in the second quadrant, cos is negative. So we're going to have negative cos k. So you have to make sure that we write everything in terms of k. Then multiply it by sine of k minus 90. So if you've got sine of k minus 90, let me show you something. I don't know how you are taught in your different schools, but we use different methods here, as I've noticed. But there are two methods that I normally use. But let me show you this one, which if you've got sine and angle minus the reduction, which is 90 there. What you can do is that you can rewrite this as sine. Then we're going to open at the corner bracket and take a negative sign outside. Then we're going to have 90 minus k. Mathematically, you can see this is one thing, because when you multiply the side, the negative sign inside, your 90 is going to be negative and your k is going to be positive. So it's basically the one and the same thing. So remember, sine of a negative angle, because now then this negative here is the negative of the whole angle, and sine of a negative angle, it's negative sine. So that is going to be negative sine, then 90 minus k, and your 90 minus is the core ratio, so it changes to its core ratio, which is cos, and that is going to be a negative cos k. So that's how you write that. So that is also negative cos k. Can I let me put it inside the bracket so that it doesn't confuse you with the negative sign. So negative cos, sorry, that's cos k, and minus 1. Oh, that's weird. Okay. Then tan squared, if you've got an angle that is bigger than 360, remember what you do need to do. You subtract 360. So when you subtract 360 there, okay, that is still going to change. It's still going to be tan k squared. So it's tan squared k. How do we know that? 360, when you subtract 36, 45, 540, sorry, minus 360, that is going to give you how much? Then you proceed from there. Then sine 90 plus, 90 plus, it just changes to its core ratio. So instead of sine, we're going to have cos k. Then cos of a negative angle. Remember, when you've got negative angles, only sine and tan will retain the negative sign, but cos is going to be positive. That is in the fourth quadrant where cos is positive. So cos of a negative angle is a positive cos. So here we are, we've written everything with only k, so we can go on and simplify everything here. The minus sign and and the minus sign for this k, I mean for cos, they're going to cancel each other. So that is going to give us this pen. It just decided to get stuck. Okay, it's back. So in negative terms, negative is positive, so we're going to have cos squared k. Oh my god, what's wrong with this pen? Okay, so we're going to have cos squared k minus 1. Then let's change tan to sine over cos. You should always write your tan with sine over cos. Everything should be written with sine over cos anyway. If it's tan, so just change it to sine over cos. So that is tan squared. So that is going to be sine squared k over cos squared k. And cos k times cos k, that is going to be cos squared k. And some of you will be tempted to cancel the cos squared k in the numerator and the 1 in the denominator. No, not at this step. You cannot do that because in the numerator you've got minus 1. So you cannot cancel between the signs there. So we do not cancel currently. But what we can cancel here is the cos here, cos squared k and the cos squared k there. They can cancel each other. Now, above the division line, we've got cos squared k minus 1. Now remember the identity which says sine squared k, it is a square identity. When you add them, they give you 1. Now let's do this. Let's rewrite this with what we see there. So if you take sine to the other side, let's take sine to the other side. Let us leave cos squared k on this side and take 1 on the other side. So it's going to be negative 1. And take sine squared k on the other side. It's going to be negative. So you can see that your cos squared k minus 1 is equal to negative sine squared k. So above the division line here, you're going to have negative sine squared k, and below that is still your negative sine squared k. It's sine squared k here. Then they cancel each other nicely. Then you are left with negative 1. And that's how you simplify that. You need to be familiar with what is happening in the cast pattern. Angles that are greater than 360, like in this case we had our 540 greater than 360. So how did I get tan squared k? Is that I subtracted 360 from 540 and I got 180. 180 plus k, that is in the third quadrant where tan is positive, so that is why it just remains tan squared in this case. And yeah, the core ratios 90 plus, minus, and the negative angles, these are the things that you really need to know how to work with. Then the next question says 6.3.2. Determine the value of k, the values of k element of 0 to 360 for which the expression is undefined. Remember what makes an expression to be undefined. If the expression it is in a fractional form, it means then that your denominator cannot be equals to 0. So we have simplified this expression and we can use it to determine the values of k that will make this expression to be undefined. So you're going to go back there and take the simplified version of the expression, which is tan squared k, and multiply by cos squared k, the one here. That is our simplified version. So we're going to take this one. So we're going to say our denominator tan squared k multiplied by cos squared k equals 0. So we have to determine what makes this to be equals to 0 so that we'll know what is going to make the expression to be undefined. So it's we've got one. This is what do you call this? The multiplication rule when we've got AB equals 0. It means then that A is equals to 0 or B equals 0. So it means here our tangent squared k equals 0 or cos squared k equals 0. It looks like those general solutions. So from there you find the value of k. For tan 0 is going to be 0, so your k here is going to be equals to 0 in this case, but that is 0 degrees. Then you get for cos here, you can just use the second function of cos. So the first one is going to be 0. You can use a calculator there. So we start off by saying cos k equals 0. Then k, second function of that is going to be 90. Let's just use the calculator for that. And remember, this can be plus or minus, or you can just take the multiples of 90. So that is going to be every 90 degrees, this is going to be undefined. So after 90 degrees, you're going to get what? 180. So that is going to be 180. You can just take the multiples of 90. 90 times 2, that is 180. And 90 multiplied by 3, that is going to be 270. And so forth. 90 multiplied by 4, which is 36. So all these values, they're going to make this expression to be undefined, and that's how you do that. I hope you do understand it. Then the next one, prove that, wow, that expression equals to 4 tan theta divided by cos theta. Yeah, so this one, you know the rule. You work with the left hand side and making sure that you reach to the right hand side. Sometimes the left hand side and the right hand side need to be simplified, both of them. Sometimes you just need to simplify the left hand side, and then your simplification equals to the right hand side. So let's start off by simplifying the left hand side. I'm not going to rewrite this, but we just going to remember these are fractions. So these fractions are subtracted. That is the first fraction, subtract the second fraction, and then we find the LCD. Our LCD is 1 minus, okay, let me write it here. Our LCD, 1 minus sine theta in brackets. So it's like you just group them together to form your LCD. Then we are simplifying. We put our LCD in our denominator, 1 minus sine theta and 1 plus sine theta. Then we go back to our equation there. We're saying that 1 minus sine theta into the LCD. So they're going to cancel. You're going to be left with 1 plus sine theta. Then you multiply it with the numerator, which is 1 plus sine theta. So you're going to have 1 plus sine theta multiplying the 1 plus sine theta that was left when we cancel out. Then there's a minus sign in between the terms. So you go to the next fraction, which is 1 minus sine theta over 1 plus sine theta. So you say 1 plus sine theta will cancel the 1 in the LCD. So you're going to be left with 1 minus sine theta multiplied by 1 minus sine theta. So that is what is left. 1 minus sine theta multiplied by 1 minus sine theta. Ah, okay. Then we continue by multiplying everything together. So in the first one, we use the FOIL method. The first one's 1 times 1, that is 1. 1 times sine theta, that is sine theta. Sine theta times 1, that is also sine of theta. Then the minus sign, we can just leave the minus sign out for now. 1 times 1 is 1. 1 times negative sine, that is negative sine theta. Negative sine theta times 1, that is also negative sine theta. Sine theta, negative sine theta multiplied by negative sine theta, that is a positive sine theta squared, or sine squared theta. And also here, because I think that is something that I left out. It is not there, but oh, how can I make such a silly mistake? This doesn't look good, but anyway, it happens. 1 times 1, that is 1. 1 times sine theta, that is positive sine theta. Sine theta times 1, that is positive sine theta. Then sine theta times sine theta, that is a positive sine squared theta. Then minus 1 times 1 is 1. 1 times negative sine theta, that is negative sine theta. Negative sine theta times 1, that is negative sine theta. Negative times positive, negative times negative, that is positive, and that is sine squared theta, all divided by your LCD. 1 minus sine theta into 1 plus sine theta. Simplifying the numerator, 1 plus sine theta, that is going to be 2 sine theta. Some of you may even get bored because of the long steps that I'm doing. I think it is necessary for some of you to understand. Then you multiply there. Okay, before we multiply, let us still simplify inside the brackets. So that is going to be 1. Negative sine theta minus sine theta, that is going to be negative 2 sine theta. And 1 minus sine theta. 1 plus sine theta. And it's going to be a very long calculation, but it's worth it. That's 5 marks. Someone would say you could have just multiplied initially. No, no, no. I want you to understand what is happening here. Um, you multiply the negative sign inside. That is minus 1 times 1. That is going to be negative 1. And you're going to have a positive 2 sine theta and the negative sine square theta when you multiply the signs inside. You do not get lazy to do all the steps. So you can cancel what is cancelable. 1 minus 1, they're going to cancel, they're going to take each other out. So 1 and negative 1, they're going to cancel. Sine square theta and negative sine square theta are going to cancel. So you're going to be left with 2 sine theta plus 2 sine theta, which is 4 sine theta, divided by, below here we have got the difference of two squares. So we can write it as 1 minus sine square theta. That is the difference of two squares, basically. So we can write it like that. Um, from here, what do? We need to work towards the right hand side, towards the right hand side, yes. Again here, our identity, I'm going to write it again. Sine squared theta plus cos squared theta is equals to 1. So when you take 1 the other side, we're going to have cos squared theta equals to 1 minus sine squared theta. So 1 minus sine squared theta is equivalent to cos squared theta. So instead of that, we have in the denominator there 1 minus sine squared theta. We're going to rewrite that as cos squared theta. Yes, and that's that. Whew. So we're going to have 4 sine theta. I'm going to separate the cos squared theta as cos theta multiplied by cos theta. So that sine over 1 of the cos theta is going to turn into tan. Sine over cos, that is going to be 4. That is tan. Remember, tan is sine over cos. So sine over 1 of the cos in the denominator, it's tan theta, and the other cos will remain cos theta. And that is equals to the right hand side. Whew, that was long. But yeah, these are the type of the questions that you need to do them once, twice, 3 times, and make sure that you master this type of questions. This was not an easy question, but I believe you do understand what is really happening now. Now the next question, it says determine the general solution of that following the following equation that is given there. So we've got 6 sine squared plus cos theta equals 4. So for you to determine the general solution, in this case, I think we need to make sure that we have got the same ratio. Since we've got sine and cos, we should convert one of the ratios. So I'll prefer to convert the first one here using the identity, the square identity. So instead of sine squared theta, remember the square identity here, the sine squared theta plus cos squared theta is equal to that. So instead of sine squared theta there, we're going to write what? Sine squared theta is going to be 1 minus cos squared theta. From the identity here, it's going to be 1 minus cos squared theta. So we're going to say here, we've got our 6 here. So instead of sine squared theta, we're going to have 1 minus cos squared theta, that in brackets, cos theta, you can say minus 4 equals 0 because it looks like we have to factorize this. Then after doing that, we multiply 6 into the brackets. 6 times 1, that is going to be 6, minus 6 cos square theta plus cos theta minus 4 equals 0. Then 6 minus 4, let's simplify this. We've got minus 6 cos square theta plus cos theta. 6 minus 4, that is going to be 2, equals 0. So from there, what we can do here is to factorize this. But first, let us make sure that our leading value here is positive. So we multiply everything by negative. So that is going to be 6 cos squared minus. I'm just multiplying everything by negative sign, and that's what we have. Then from there we factorize. Factors of 6 are 3 and 2, so we can have what? 3 cos theta and 2 cos theta. And factors of 2 are 2 and 1, but the question is where do you put the 2 and where do you put the 1? So remember we've got, if we've got 3x and 2x, and then you got the factors of 2, you put your 2 there and your 1 there. 3 times 3x times 1, that is going to be 3x, and 2 times 2x, that is going to be 4x. And our interest is the middle term, which is we've got a negative 1. So for us to get a negative 1, it means the bigger factor must be negative here. This must be negative and that must be positive, because 3x minus 4x, that is going to be negative x. So for 4 to be negative, it means the 2 has to be negative and the 1 must be positive. So we're going to have minus 2 and plus 1 in this case. So that's what we have there. I hope you do understand this, what I've been doing. This type of questions are very long questions. Trigonometric questions are very, very, very long questions. And now my eraser doesn't want to move away. Give away for a pen. Now from there, you know the rule here. Your cos theta is going to be equals to 2 over 3. I hope everyone knows where does that come from. We are at the stage where everything should be clear now, and this is going to be equals to negative 1 over 2. So from there, use the second function, your theta, second function cos, for arc cos 2 over 3, and you do the very same thing there. Then you get your reference angles. Your theta is going to be equals to 48,19. Remember, for the general solution, you need to add, that is the degrees, you need to add k multiplied by 360, as this repeats every 360 degrees, or use a calculator there. The theta is going to be equals to cos 360 minus, it is positive, that is 360 minus. So that is going to be 360 minus the reference angle, that is going to be 311,81 plus k 360. So those are the solutions for the first one. The solutions for the second one, allow me to use a different color here. So I'm going to do the solutions for this one. So I'm going to have theta equals to 120 plus k 360 degrees, or theta equals to, that was negative So it's negative in the second quadrant and also in the third quadrant. So 180 minus that is going to be 240 plus k 360. Remember, with cos you can just use plus minus. So some people prefer to use plus minus. So you can see plus minus the reference angle on both your solutions. So that is also going to work. So that's how you do your general solution basically. Then the next question. 6.6, if P equals tan A plus sine A and Q is equal to tan A minus sine A, prove that PQ is equal to tan squared A multiplied by sin squared A. What a question. But anyway, this question leads you on what to do. Since you've got P and Q and you're told that the product of that is whatever there. So it means you have to multiply P and Q from the given statement. So we are going to say your PQ. So you take the P value, which is tan A plus sine A. Then you're going to multiply. Okay, since there are two terms, let's put them in brackets. So you're going to multiply them with tan A minus sine A, which is Q. So we're going to go on and FOIL them out. Tan A multiplied by tan A, that is tan squared A. Tan A multiplied by sine, negative sine, that is negative sine A tan A. And this one is going to be sine A multiplied by tan A, that is positive sine A. Someone would say that step is not even necessary. You should have just cancelled them. Then the next one, you multiply the last one, so that is going to be sine squared A. So you can see that sine squared, tan squared and sine squared are the ones that are going to remain, whereas the middle term are going to cancel out. So I'm going to be left with tan squared A minus sine squared A. Then tan can be changed into the sine, that is sine over cos, sine squared A over cos squared A minus sine squared A. And that is, you can put this over 1 because you've got a fraction on the left hand side and a fraction on the right hand side, and you're subtracting that, and you take the LCD, which is the lowest common factor, which is cos squared A. So you say cos squared A into cos squared A, that is 1 multiplied by sine squared A, it remains sine squared A. 1 into cos squared A goes cos squared A times, then you multiply those, that is going to be sine squared A multiplied by cos squared A, because that is what remains, then you multiply them together. So in the numerator, we've got two terms, and then something similar there. So it's going to be the highest common factor. You've got sine squared A on one term and sine squared A on the other term. So your sine squared A is going to be our highest common factor. You take it out, then you go back and divide by the highest common factor. You're going to be left with 1 on the first term, and you divide again on the second term. They're going to cancel out. You're going to be left with cos squared A all over your cos squared A, and you do not cancel the cos squared A's. Then again, this is the identity, which your 1 minus cos squared A, remember, is sine squared A. in this case. And sine over cos is tan. So you're going to convert sine over cos as tan squared A, and 1 minus cos squared A, it is the identity, which is what? Sine squared A. And that is your PQ, and you have proven that it is equal to that. Wow, what a question. Whew, I wasn't even breathing properly. Yeah. So that's how you do your trigonometry. You need to be able to use algebra all through in your trigonometry, but do not forget to change your tan into sine over cos, and also use the square identities, or yeah, the identities that you know for grade 11. And yeah, from me, thank you so much for watching until to this end. And please don't forget to watch the subsequent video. This is part 2, and part 3 will be coming. That's why we're going to continue with 2D trigonometry and geometry, and also the functions, trigonometric functions. Thank you. See you in the next one.